Hey guys, this is going to be my video for the first half of section 3 in chapter 5. 5.3, really important stuff. This we're going to have some quizzes just on this section alone. So I wanted to make a video for the first half and go through it really thoroughly, and then the second half because it warrants that much attention. We've seen in sections 5.1 how to graph quadratics, and section 2, how we can use those graphs to find the solutions, where they hit the x-axis. And I showed you how to do that by hand. I showed you how to do that on a calculator. Today is where we're going to start talking about ways we can solve quadratic equations algebraically. In other words, not having to graph, not having to rely on the kind of imprecise nature of graphing. And so 5.3 has to do with a method called factoring. You've probably seen this before. Most of the time when students get to this part of the course, they say, okay, I kind of remember that, but I remember I wasn't good at it. Well, you're going to get really good at it because this is as important a new skill as there is in first semester. I would say this is the most important new skill in first semester. And then there's one other one that's kind of equally important second semester that we're just going to be driving home. So buckle up, get ready for factoring. And we're going to kind of lead this through first conceptually and then just work a bunch of problems. So conceptually, if we have two values, a times b, and we know that a times b equals 0, we know something. What do we know about a or b? We know that a has to equal 0 or b has to equal 0. And this seems like a deceptively simple concept. But this is what the idea of factoring and solving quadratic equations by factoring is built on. If you have two numbers multiplying to be 0, the only way that happens is if one of them is 0. You've probably talked about that in when you were younger in previous classes. You might just intuitively know that the only way I multiply two things and get 0 is if one of them or both of them is 0, right? It could be both. But we know that multiplying two things equaling 0, that means that one of those two is 0. So here's where I'm going to move this conversation into the realm of quadratic equations. If x plus 6 times x minus 4 equals 0, then one of two things must be true. This is the exact same statement as what we had above. Either x plus 6 has to equal 0, so that we would get 0 times the x minus 4, and that would give us 0. Or x minus 4 equals 0. And again, conceptually, I want you to take a few seconds to think about this and really lock it in, because we've got two things multiplied to be 0. That means one of them or both of them have to equal 0. Now, this is actually really cool and good news for us because it's really easy to find the solutions then. If x plus 6 equals 0, we know how to solve that. That means that x would equal negative 6, right? So negative 6 is one possible solution to this quadratic equation. Or, though, there was another possibility, x minus 4 could have equaled 0. Add 4 on each side. That means x equals positive 4. And there are two solutions to this quadratic equation. Because they equaled 0, because they were multiplied by each other, one of them has to equal 0 at least, so we know the two possibilities. X plus 6 equals 0, which means x would have to be negative 6, or x minus 4 equals 0, which means x had to equal 4. You might be looking at this and saying, wow, this is pretty easy then, because we have those two things multiplied, we just set them equal to 0 and solve. Yes, but the trick of the day is going to be turning quadratic equations, ax squared plus bx plus c, into something that looks like this, two things being multiplied together. And that is the definition of factoring. That is finding two factors that we can multiply together so that we can use this simple strategy. Now, just a quick reminder about this word here, roots. Roots are where we hit the x-axis if we graphed it. Roots are the solutions. And so these guys are our solutions, we said. They're also the roots and x-intercepts and zeros and all those other names that I talked about in that previous video. So take a look here. X plus 6 times x minus 4. That's what we just did. If we FOILed them together, we could get x times x is x squared, negative 4x's plus 6x's, so that's plus 2x's, minus 24. Okay, so we know we can FOIL to go from two binomial factors, into our polynomial. But now we need to go backwards. We want to start changing colors. We want to start here and figure out what those factors are, end up there. Because then it's really easy to solve the quadratic equation like we saw. So I'm going to make two quick statements, and then I'm going to go to those steps below, and then we're working problems. First quick statement that I want you to notice is that positive 6 times negative 4 equaled negative 24, right? Those numbers at the end of those binomials, plus 6 and negative 4, need to multiply to be negative 24, our C value at the end. Now, the other thing I would point out is positive 6 and negative 4, if we add them together, they're going to equal this positive 2x's. So positive 2, I should say, because we aren't talking about x's just yet. 6 plus negative 4 equals 2. Now, this is going to hold true for today, okay? Today is the first half of this section, which is factoring when we have just one x squared. If we have multiple x squareds, these rules change slightly, and I'll be demonstrating that in my next video. But here, we're going to start seeing these patterns that we can use where if we have 1x squared, then we know those two numbers in the binomials have to multiply to be C and add to be B. Let's take a look. So when we are factoring and solving quadratic equations by factoring, step one is always check for common factors, meaning can we pull anything out? Can we pull anything out, divide anything out of the equation? If yes, do so, but if you do and it's not quite factored yet, or you don't, and it's obviously not factored, then here's what we're going to do. We're going to set up binomials. We're going to set up our parentheses. If the leading coefficient is 1, if we have 1x squared, we can just insert x's straight away. That's what we're looking at today. So today we're going to be doing step 2b every time. We're going to insert signs. That's kind of cryptic, but I will explain what that means here in just a second when we're looking at problems. We're going to figure out those second terms, and we're going to mentally check to see if we FOIL our answer out, if we get what we started with. So pause the video, write this down, get down what you need. After a day, 2 days, a week, this is going to become second nature to you, but for now you might want that kind of step-by-step. So factor the following in red and then solve in green. These are two different questions being asked. So factor the following says we're trying to factor these down as much as we can, hopefully get them all to x to the first factors. We have y equals x squared minus 2x. So if I'm factoring, step one said pull out anything you can. Well, I can definitely pull out 1x, right? I can say this is x, I can pull it out to the front, times x minus 2, because x was a common, was common to both of those terms. X squared minus 2x, I can pull that x out. Notice now that we don't have any x squareds the way it's written. It's just x to the first. That is factored. If the problem says factor, you leave it right there. If it says solve, though, we have to do what we were doing earlier. We're going to set it equal to 0. We're going to say, okay, if we're solving, that means y equals 0. So 0 equals x times x minus 2. And notice what we've got going on here. Just like we spent a significant deal of time at the beginning of this video discussing, we have something times something else equals 0. So that means either this guy has to equal 0, x equals 0, that would make this a true statement, or this guy has to equal 0, because that's the only way we multiply two things and get 0. at which point add 2 to both sides, x equals 2. So this is just one example of, I think, 8 that I put on these notes for today. If we have a problem that asks us to just factor, we leave it where it's at in red. But if it asks us to solve, we actually have to find x values, okay? What about this one? Y equals x squared minus 16. There's nothing really to pull out there. I can't pull an x out of all the terms on the right. So to factor, we're going to go back to that step 2. And so you wrote these down. Hopefully you have them in your notes. You're looking at them. Set up your binomials, insert x's if the leading coefficient is 1, insert signs, figure out second terms, and then check. So here we go. Y equals, I'm going to set up my binomials. And that's all that means. I like just putting those parentheses down. It gives me a reminder, okay, I know what I'm doing. If the leading coefficient is 1, meaning if we have 1x squared, which I said is everything we're looking at today, there's only one way to multiply two binomials here and get 1x squared. Only one way that we're looking at right now anyway. X times x, right? X times x is x squared. So that's what that step 2b was talking about. Now I've got my binomial set up. Now I've got x times x, and that comes to then 2c. And this is where we got to do a little bit of thinking. 2c says insert signs, and I promised to explain that later. Well, now is later. We want to look at this sign for the c value. Is c positive or negative? Well, c in this problem is negative, negative 16. And if that's a negative, then I know I have 1 plus and 1 minus. I know my signs have to be different. This is really important that you understand this. The only way we're going to multiply these binomials and get negative 16 at the end is if we have a positive times a negative. Because a positive times a negative will give us this negative. What if it was a positive times a positive? Well, a positive times a positive would give us a positive, so it wouldn't work here. What about a negative times a negative? Would also give us a positive, also wouldn't work here. So if the c value has a negative, you can insert two signs into your binomials. It's a plus and a minus. Okay, plus and a minus, that's what insert signs means. I'm going to keep going over that. You'll keep seeing lots of different examples. But on to step 2D, which is figure out the numbers. We need two numbers that multiply to be my c value and add to be my b value. Okay? And this is something when the leading coefficient is 1, when we have just 1x squared, this is how you can always do it. Multiply to be c. So they need to multiply to be negative 16, but at the same time add to be 0. We don't have any x's, so b is 0. So what are two numbers that multiply to be negative 16 but add to be 0? How about 4 and negative 4? 4 times negative 4 is negative 16. 4 plus negative 4, they cancel out, is 0. So we have our plus 4, our minus 4, that's our positive 4, our negative 4. And guys, this is the factored form of our original equation. Y equals x plus 4 times x minus 4. So step 1, we set up our binomials. Step 2, we inserted our x's because it was just 1x squared. Step 3, we figured out the signs. We said, okay, if c is negative, we have one of each sign. They're different, a positive and a negative. And then D, we said, okay, multiply to be negative 16, add to be 0. We had to figure out those numbers, and it was plus 4 and minus 4. So this is how we come up with factors. 2E says check. Well, I'm going to really quickly FOIL this out in my head. I'll put it on the screen for this one. X times x is x squared. X times negative 4 is minus 4x's, but then we have 4 times x, so plus 4x's, minus 16. So negative 4x's plus 4x's, that just gives us x squared minus 16, which is what we started with. We are good to go. check complete. Okay, so once again, if the question had just said factor, red is where we go. We're done. Solving says make y equal to 0. So we have x plus 4 times x minus 4 equals 0. And we know that in order to multiply and get 0, one of those has to be 0, right? So either x plus 4 equals 0, subtract the 4, meaning x equals negative 4, or x minus 4 equals 0, which means add 4 to both sides, x equals 4. Those would be my two solutions. X equals positive or negative 4, plus or minus 4. Okay, so once you have it in factored form, you'll notice you can just say, what x can I plug in there to make that equal 0? And you're like, negative 4 plus 4 would equal 0. What x would I plug in there to make that factor equal 0? Positive 4. Those are your two solutions. Let's do another one. Aha, here's one with a more visible b. So y equals x squared plus 4x plus 4. Step 1, can we pull anything out? Unfortunately, no. I know we see the 4 and the 4, but the x squared term doesn't have a 4. We have x squared and x, but then that c term at the end, the constant term, doesn't have an x, so we can't pull anything out, which means I'm going to go ahead and start my process. Set up my binomials. It's just a single x squared, which is what we're looking at today, so I know I can put in x times x. So now it says insert signs. Now I mentioned earlier, we always look at the sign of the c value. In this case, it's positive. So this takes an extra step then, a half step, because they could be plus plus, because a positive times a positive would get us this positive right here. But they could also be minus minus, right? Because a minus times a minus would also get us this positive here. So how do we know if the c sign is a plus, if it's a positive number, c, we know the signs are the same. Has to be positive positive or negative negative. And how do we tell then which one they are? We look at the sign of b. b is positive. We use two pluses. So the sign of c tells us, okay, the signs are the same. And we look to b to figure out what those signs are. X plus, X plus. Now we're over here and saying, okay, so I'm looking for two numbers that multiply to be c. So they need to multiply to be positive 4. They need to add to be b, which is also 4. So what two numbers multiply to be 4 and add to be 4? Positive 2 and positive 2. 2 times 2 is 4. 2 plus 2 is 4. X plus 2, X plus 2. We can do a quick check. So that'd be x squared plus 2x, so plus 4x total, plus 4. I'm just foiling it kind of in my head, and you want to be able to get to that point so you don't always have to write it down. It does check out. There's my factored form. What about solving? We set it equal to 0. 0 equals x plus 2 times x plus 2. So either x plus 2 equals 0, meaning x equals negative 2, or x plus 2 equals 0, meaning x equals negative 2. They're the same answer. This is, if you remember back to the last section, 5.2, we said sometimes we'll only have one solution. This is a great example of that. There's only one solution, x equals negative 2, because this is kind of a duplicate, right? It says the exact same thing. Factoring, super important. We're going to keep cranking through these. I'll go a little bit quicker. Y equals negative 3 times x squared plus 27. Can we factor anything out? Well, both terms have a factor of 3, and I might even recommend negative 3. Let's pull out a negative 3 to make our x's positive, because that's what we want. So y equals, pull out a negative 3, that leaves us with x squared, and what happens if we pull out negative 3 from 27? X squared minus 9. So how does the negative 3 play a part in this? It's just going to come along for the ride. We're just going to factor the inside of those parentheses. Negative 3 is just going to come along for the ride. Y equals negative 3. I need to factor that next part. So I'm going to set up my binomials. I'm going to put x and x because it was just 1x squared. Looking at the sign of my c value, it's negative. So we know that we have different signs in here, plus and minus. And now I'm looking for two numbers that multiply to be c, so multiply to be -9, but they add to be b. Add to be, we don't have any just x's, so add to be 0. And you think for a second, what two numbers multiply to be -9, but add to be 0? 3 and -3. So +3, I'll put it with the plus, -3, I'll put it with the minus. This is looking like our factored form. And like I said, we can always check it. I'll FOIL this out, so x squared plus 3x, but minus 3x. So those are gone. And then -9 times -3. That was just along for the ride. -3x squared plus 27. That's what we started with. Check complete. We factored it correctly. What about solving here? Well, I know I'm setting equal to 0. But now I have three things that are being multiplied together. So could there be three solutions? Well, the answer is no. We saw that in the last video, but if there can't be three solutions, how does this work? Well, we say, okay, so we need to find what will make each of these factors 0. Can I ever make -3, because that's the whole factor, that's what's being multiplied. Can I ever make that equal to 0? No, it's a different number, it's -3. So that one doesn't give me a solution. What would make x plus 3 equal to 0? Well, if x were -3, that would do it. What would make x minus 3 equal to 0? Well, add 3 to the other side, x equals +3, that would do it. There are my solutions. Once again, there's no way for me to just take that factor and make it equal to 0. So it doesn't contribute a solution. We get our two solutions, x equals -3, x equals +3. Okay, let's keep it going. X squared minus 6x plus 9. Can't pull anything out. They don't all have x's. They don't all have a factor of 3, looks like the closest. So I'm just going to come here. I'm going to set up my parentheses for my binomials. And I would challenge you at this point, maybe pause the video, maybe try this one on your own. And then unpause it to see if we get the same thing. So feel free to do that now. I'm going to start working this out. If you paused it, great. See if it matches yours. If you didn't, and you're still getting the hang of it, follow along. I know since it's 1x squared, I know it's x and x. I'm looking here, and I know my c value sign is positive, which means the signs are the same, but I don't know what they are, so I look back to the b sign. They are both negative. And I need two numbers that multiply to be c, so they need to multiply to be +9, add to be -6. What multiplies to be 9 but adds to be -6? How about -3 and -3? -3 times -3 is 9, -3 plus -3 is -6. And I knew they were both minuses because of my signs. So -3 is inside there. There we go. It's factored. Y equals x minus 3 times x minus 3. You can mentally check that and FOIL it out. X squared minus 3x's minus 3x's, so minus 6x's total, plus 9. Looks like it works. What about the solutions? We set it equal to 0. And then we say if it's equaling 0, one of these at least has to be 0. So how would we get x minus 3 equaling 0 if x were 3? How would we get x minus 3 equaling 0? Well, if x were 3, this is another case of that duplicate double solution. Duplicate, if I spelled that correctly. X equals 3 is how we're going to make this equal 0. X equals 3 is my only solution. How about this one? I like this one. Y equals x squared plus 6x plus 8. Can't factor anything out. They don't all share any common factors. So y equals, set up your parentheses. Feel free to pause it and work this one again if you want, if you're feeling really good about this. X squared, how am I going to get x squared? X times x. What do I know about my signs? I know they're the same because that's a plus. And so I look back and it looks like they're both positive. So I'm looking for two positive numbers that multiplied together equal my C value. So multiply to be 8, add to be 6. Multiply to be 8, add to be 6. Sounds a lot like 4 and 2. X plus 4, x plus 2. Can kind of check it mentally. X squared, if we FOIL, plus 2x plus 4x is plus 6x is total. And then plus 8, looking good. How about solving? Set it equal to 0. And then say one of those at least has to be 0. So what would make x plus 4 equal to 0? If x were negative 4, subtract the 4 over. What would make x plus 2 equal to 0? Subtract the 2 over, x equals negative 2. Those are our answers. It should be mentioned that this way of finding our solutions would match if we decided to graph these, for example, like we saw in 5.2, we would get the exact same solutions. Okay, this is just an algebraic way to do it without the graph. All right, last two. Y equals x squared plus 4x minus 45. If you haven't already been pausing, then I want you to try this one on your own. See how far you get. See if you get stuck, that's okay. I'm gonna go through it here in just a second. You'll be able to follow along, but I want you to see where are you at with this process. So if we have y equals, and ignore my phone ringing in the background, sorry about that. There's nothing to pull out, so binomials, we're setting them up. X squared, the only way I'm getting that is x and x. What do I know about my signs in these binomials? Well, C is negative, so I know they're different. One of each, because a positive times a negative is how I'm going to get that negative. So at this point then, I'm looking for two numbers, one positive, one negative, that multiply to be negative 45 and add to be 4. So you might have to think about this one for a second, 45 and 1. What about 9 and 5? 9 and 5 sounds promising, except one of them has to be positive, one of them is negative. I think I'm going to make my 9 positive because they need to add to be positive 4. So I want more positives. So 9 plus negative 5 is 4. 9 times negative 5 is negative 45. I'm feeling good about this. So I'll put the 9 with the plus, the 5 with the minus in my binomials. And there we are. Check it in your head, x squared minus 5x's, but then plus 9x's gives us plus 4x's overall, minus 45, we are in business. And then we'll go ahead and solve it. X plus 9, x minus 5, we know we're setting it equal to 0. So one of these has to equal 0. So if x plus 9 equals 0, that means x equals negative 9. And if x minus 5 equals 0, that means x has to equal positive 5. There are my two solutions. Last problem, and I'm kind of throwing a curveball at you with this last problem, because I guess I lied earlier. I said we were only looking when we had one x squared. So this is kind of a lead into my next video of part 2 of this section, because we said that we only are looking when there's 1x squared. Well, here that's not true. We actually have negative 1x squared. So here's what I'm going to do. I'm going to take this, and I'm just going to pull a negative out. Kind of like we pulled the 3 out earlier. We had that other example like this. X squared minus 2x minus 15. Remember, pulling a negative out just changes all the signs. And we could check that by distributing the negative back in and make sure we have what we started with. What does that negative do? It just stays on the outside and comes along for the factoring ride. Y equals negative. I know I need to factor that inside, so I'm going to set up my binomials. Now it's just x squared. I'm going to make it x and x. What do I know about my signs? Well, because of that C value being negative, I know that I have one of each. They're different. And I know I'm looking for two numbers that multiply to be the C value, multiply to be negative 15, add to be negative 2. So two numbers that multiply to be negative 15, add to be negative 2. I know they have one's positive, one's negative. So I'm thinking negative 5 and positive 3. Negative 5 times 3 is negative 15. Add them together, you get negative 2. So I'm going to put my 5 over here with the minus binomial so that it's negative 5, and the 3 right here, x plus 3, to make it a positive 3 in that binomial. And right there we have our factored quadratic equation. To solve, we're going to set it equal to 0. Y equals, 0 equals negative x plus 3 times x minus 5. Once again, the negative 1 out front, is there any way we can make that equal to 0? No. So it does not contribute a solution. It is part of the equation, but it doesn't give us a solution. Is there any way I can make x plus 3 equal to 0? Well, yeah, if I subtract the 3 on both sides, x equals negative 3. And is there any way I can make that x minus 5 equal to 0? Same thing, I'm just going to add the 5 on both sides. And it looks like this is another one that has two solutions. X equals negative 3, x equals 5. Guys, this is a lot to throw at you, a lot of practice, and this is half of the section. That's why I wanted to break this one up into 2 videos. But this, you can't, gosh, you gotta get this down to where it's muscle memory, where you're setting up your binomials, you're putting the x's in, you're figuring out the signs, and you're figuring out, okay, I have two numbers that need to multiply to be negative 45, add to be 4, and I know my times tables, 9 and negative 5. This has to become muscle memory, not today, not tomorrow, but within the next couple weeks. You're going to want to be able to do this just without even thinking about it. And so we're going to get lots of practice. We're going to have assignments and quizzes that are just this, just lots of factoring practice. That's how important this is. It's kind of like when you were in elementary school and knowing your times tables, being able to say, oh, 5 times 4, that's 20. And that was really important because now you can use that in longer problems. You don't have to even think about that. These are the new times tables. You got to know how to factor. So we're going to get lots and lots of practice with them. I'm hoping this made sense. If it didn't, honestly, go back and watch this video again. Rewind and watch a couple problems again. Try the problems that I give you for practice and see if you're getting the answers you should be getting. But this is a really, really important skill. This is 5.3 video 1. And then in video 2, we're going to see some special cases and how do we handle it if the leading coefficient, the number of x squareds we have, isn't 1. How do we do that? What strategies do we have if we can't factor it out so that that leading coefficient is 1? That's all for this video. Once again, if you had questions, let me know next time we talk. Otherwise, I will see you next time.